Everyone, this is Mr. Hawkins. Um, welcome to my math video. Today we're going to be learning about the converse of the Pythagorean theorem. So the converse of a statement switches the order of if and then in the statement. Use this to write the converse of the following statement as an example. So if I said, if it rained, then the animals are wet. The converse of that would be if the animals are wet, then it rained. So I'm switching basically the if conditional statement and the conclusion of the statement. So here it says if a triangle has 3 equal sides, then it's an equilateral triangle. So I switch the if part with this, and then the then part with this, and say if a triangle is equilateral, then it has 3 equal sides. So it's kind of like reversing the order of our statement. So let's look at see how this applies to the Pythagorean theorem. So we say that we know that if a triangle is a right triangle, then a squared plus b squared equals c squared. That's our Pythagorean theorem. Apply the practice from above to write the converse, the Pythagorean theorem. So remember, we're switching the if conditional statement and then the then statement. We're reversing it. So we would say if a squared plus b squared equals c squared, then the triangle is a right triangle. So the converse can be used to prove whether a triangle is a right triangle or not. So let me switch over to this one that doesn't have all the answers. And let's look at this and say, it says in 1 through 3, use the Pythagorean converse to prove whether the given triangle is a right triangle. Show all work in the first column, then write yes or no to justify your answer choice in the last column. So this is the right answer and a justification. So it wants to know if this thing is a right triangle. Well, from what we learned about right triangles in our last video, we learned that the short sides are near our right angle, or our supposed right angle, right here. And then the long side should be straight across from it, right here. So this would be A, this would be B, and this would be C in this case. So we could say if A squared plus B squared equals C squared, then this thing is indeed a right triangle. So why don't we test it and see if it works? So A squared, so remember that's A times A, plus B times B equals C times C. So now we plug in A, B, and C because we've identified our legs and our hypotenuse. So 30 times 30, that's our A, plus 15 times 15. Does that equal 45 times 45? So I'm going to put an equals question mark because I'm seeing if this is true or not. So I'm saying equals question mark 45 times 45 because I'm asking the question, does this thing, is it true? If it's true, these two sides should be equal. If it's not true, what do you think is going to happen? The two sides won't be equal. So 30 times 30 is 900 because 3 times 3 is 9. 15 times 15 is 225. There's a trick for that. If you want, I can teach you later. And 45 times 45 is 20, 25. So now I'm just going to add my two sides together. Oh yeah, don't forget the question mark because we're seeing if it equals. And then we're answering finally when we come to this conclusion, the question, does 1125 equal 2025? And the answer, of course, is no. So instead of a question mark, we can put a slash through the equal sign, or you can say, this is how a programmer would type it. Equals slash means not equals. So we can say, no, it's not a right triangle. This is not a right triangle at all because it does not follow the Pythagorean theorem, a squared plus b squared equals c squared. So we say no, because a squared plus b squared does not equal c squared. I'm going to put that slash again. And there's our work for it. So let's look at the next one. We got 15, we got 12, and we have 21. So we're going to set it up in the same way. So we're going to say, okay, does a squared plus b squared equal c squared? So identify your longest side, because we always start with identification. That's going to be our c. And then these two sides will be our a and b. Because it's important to know where we're going to plug stuff in. So this guy is going to be our b value right here. So now let's plug it into our Pythagorean theorem. And we can say, okay, 15 times 15 plus 12 times 12. Does this equal question mark 21 times 21? So this is a little bit too big. I'm going to squeeze it down. There we go. So next, we're going to answer that question. We're going to say, okay, 15 times 15. Plug it in our calculator. Calculate, calculate. Okay, it's 225. Perfect. 12 times 12. Hopefully you know that, but if you don't, that's okay. Plug it in your calculator, and you're like, oh, okay, 144. And then does that equal 21 times 21? Well, plug that in your calculator. 20 times 20 is 400. 1 times 2 is 2. 2 times 1 is 2. That is 4. 1 times 1 is 1. So that's 1, 4, 4. So I could teach you that trick later on, but just for now, plug it in your calculator if you want. So 441. And then just add 225 plus 114. What is that? Well, that's 3, 6, 9. Does that equal question mark 441? No, it doesn't. No, it doesn't equal that. So we say, okay, I know now that this does not equal. So I'm going to say no right triangle. And then I can say 369 does not equal 441. Next one, 18, 24, and 30. So I'm going to do the same thing. I'm going to say, okay, if I use the Pythagorean theorem, will my short side squared equal my long side squared? Well, first let's identify my sides. So I look at my long side. Okay, I know 30 is longer than both of them. That must be C. And then this must be my A because they're my shorter sides, and my B. Now, does it matter what short side do you call A and B? Not really, just as long as you call the long side C. So I learned my lesson from last time. And I'm going to say, okay, 18 times 18 plus 24 times 24. Nope. Does this equal question mark? Because remember, I'm asking my question. 30 times 30. 18 times 18. So I'm cheating a little bit here. 324 plus 24 times 24. 576 equals 900. Does that equal 900? Well, just add the two together. So 4 and 6 is 0. Carry the 1. 3 and 7 is 0. Carry the 1. 3 and 5 is 8. Plus 1 is 9. So 900 does indeed equal 900. So it's no longer a question. We know that 900 is 900. So we say yes. Golly gosh, yes. It is equal. And then we could say, okay, yes, this thing is a right triangle. Hooray, we have done it. We have solved the mystery of what is a right triangle and what is not by using some basic math. All right, as always, I'm going to leave the next page to you guys and the Blackboard assignment. So go ahead, fill it in as you complete your Blackboard assignment because it's the same questions. And that way I know you at least did your notes. Thank you.